Question number 1, we have a ray of light coming from air going into diamond, and the angle of incidence is given to us as 20 degrees, so that's theta sub 1 or theta sub I. And we want to find out the angle of refraction. That's the theta sub 2, or it might be theta sub r in some places. From our table in the side of the homework or in your notes, we know that the index of refraction for the first material that the light is in, the air, is 1.00029. And then the index of refraction for diamond is going to be 2.41. So we put all those numbers into Snell's law. N1 sine of theta 1 equals N2 sine of theta 2. So for N1, we put 1.00029. If you want to just put in 1 for that and forget about the 29, it's still going to be just fine. It's so close. Theta sub 1 is the 20. N2, we put in the 2.41, and then we're looking for the theta sub 2. So doing our calculator, we can see the left-hand side is going to be 0.342. That's rounded. And so we're going to divide both sides by 2.41, and we get 0.142 is equal to the sine of theta 2. But we don't want to know what the sine of theta is. We want to know just plain old theta. So we need to do the inverse sine. That's where you have to hit the second button on your calculator. And when we do that, we'll find out the angle is 8.1 degrees. So make sure that your calculator is in the degree mode, otherwise you're going to get a different answer. Question number 2. In number 2, we have light going from alcohol into water. Just like oil floats on water, alcohol can as well. So the angle of incidence is given to us as 25 degrees. We are looking for the angle of refraction, theta sub 2. From our tables in our notes or in the homework, we know that the index for the alcohol is 1.36 and for water 1.33. We're going to put all these numbers into Snell's law. And so we get 1.36 for the N1. That's the first material that the light is in. Sine of 25, the angle of incidence, the first angle that is made, equals 1.33 sine of the unknown. The left-hand side gets to be 0.432. That is also by dividing both sides by 1.33 at the same time. But this 0.432, that's equal to the sine of theta. You got to do the inverse sine in order to find out what the plain old angle is. And that turns out to be 25.6. Question number 3. In this case, we know both angles. Light goes from plastic into glass, so the first material it's in is the plastic. The second material is the glass. The first angle is 25 degrees, that's theta sub 1. The second angle, or the angle of refraction, is 35. We know the second index of refraction. We want to know the first index, the index of the first material, the plastic. So we're going to be using Snell's law, but this time it's the n that is the unknown. Now that unknown n up here is in the first material, and the first angle is 25, so you've got to make sure that it's matching up with the right pairs. So sine of 25 goes with the unknown. 1.33 and the 35 degrees goes together because they're in the same material and the same glass. Changing things to decimals and multiplying, we get 0.76 over here, 0.42 on the left. Divide both sides by 0.42 and you get 1.8. You can do this all in one step if you want. Go directly from the substitution line down to the 1.8 if you're fancy with your calculator. But be careful, the more things you try to do all at once on your calculator, the more likely it is that you'll make a mistake. Question number 4. We have light going from a vacuum into some kind of plastic. The angle of incidence is given to us as 15. The angle of refraction, or the second angle, is 18. We know the index of refraction for vacuum. We're going to try to figure out the index for the plastic. So this is in the second material. It's going to be paired up on the same side as the angle in the second material. So we can see that over here. It's going to be on the right-hand side that we have the unknown paired up with the 18. Okay, in a vacuum, n is 1, and the angle in the vacuum is 15. The left-hand side decimal version is 0.259. On the right-hand side, sine of 18 is 0.309. Divide both sides by 0.309 and you get 0.838. Now this is impossible because all n values are always greater than 1. And so since we got a 0.8 here, that means that the story problem is just make-believe. It never would have those kinds of results in reality. Number 5. We have light that starts off in the gray block and it's leaving. Now there are all sorts of angles given to us in the story problem in your homework, but we are only concerned about the angles between the ray and the dotted line. So I'm going to ignore the other angles that are given to you. These are the only ones we use. We don't know the index of the first material, where it starts off. We know the index of the outside material, which is air. That is 1.00029. Once again, you can just abbreviate that to be 1 if you want. So putting this into the Snell's law, the N1 is the unknown. The first angle is 40 in the first material here. N2 is the 1.00029. And the outside angle is 60. So that goes over here in theta sub 2. Sine of 40 is 0.64. The 1.00029 times the sine of 60 is 0.866. Divide both sides by 0.64 and you'll get 1.35. For number 6, we're going to use this number. We want to figure out what's the speed of light in this material. So we use the definition for the index of refraction. This is the thing that we learned last chapter. The n we just figured out to be 1.35. C is the speed of light in a vacuum. That is always going to be 3 times 10 to the 8th. And we divide that by the velocity in the material. That's what we're trying to figure out. So if you do your math correctly, remember one way of doing this is to make it a proportion by putting that over 1, cross multiplying and dividing, and you'll get 222 million. 2222222. So that's how we do that day's homework. You can now proceed and do the next homework.